Okay, let's look into this question. An interesting question. The question says, how many 4-digit numbers are there such that they end in 83? That is, the tens digit is 8 and unit digit is 3 and are divisible by 11. First of all, I would like to ask you how many such numbers are there in all. So if you suppose that a number of that sort is of the form AB83, this A position can be filled by 9 numbers, and if I assume that repetition is allowed for such numbers, B can be filled in 10 ways. Okay, and obviously for these two there is only one way. So in all, total 90 such numbers are possible. Okay, of these 90 numbers, we are supposed to calculate the numbers which are divisible by 11. So this would be a good time for us to understand what is the divisibility rule of 11. The divisibility rule of 11 says that the sum of the, I'm quoting, please pay attention to this, the sum of the digits starting from the unit digit alternately minus the sum of the digits starting from the tens digit alternately should be divisible by 11, or the difference should be 0. In other words, u minus t is equals to 0 or divisible by 11. This is what the divisibility rule of 11 says. Now this is a very peculiar divisibility rule, and seldom it is happening that students remember this thing. Please remember that the positions vacant over here, A and B, needs to be filled by us. So we will have to do some arithmetic over here. So let's do that. Okay. Not very difficult, but at the same time not very easy also. So let's do one thing. Let's try and understand what the u minus t equals to 0 means. So if I add the numbers starting from, or rather add the digits starting from the unit digits in the alternate way, this can be written as b plus 3 minus a plus 8. That should be equals to 0. Now this is one of the cases. Okay, I should remind you that this is case number 1, because the other case is that the difference of these numbers can be divisible by 11 also. Okay, so this thing can be written as b minus a minus 5 is equals to 0. Now please remember, this is not an equation, this is an expression. The difference between an equation and an expression is that the expression can be a little bit loose in terms of the variables that are present there. Equations are pretty rigid. Okay, for example, what I would like to say is that this expression can be written as b minus a is equals to 5. Now with this much information, I think I can pretty much fill up the numbers so that this a position and b position can be filled. So I will start off by a bigger number in b, or vice versa. So let's do that. So 9 and 4, the pair, can give me 5. 8 and 3, the pair, can give me 5. 7 and 2 can give me 5. And 6 and 1 will also give me 5. So these are the pairs that can be filled. One thing that you need to remember is that these numbers, these 4 numbers, can be filled in only one way. For example, what I'm trying to say is the number which is going to be 9483 is not going to be equals to 4983. One of these numbers is actually divisible by 11 and the other one is not. Now let's try and figure out which of these numbers are divisible by 11. So let's look into the alternate numbers. So if you look into the alternate number, this is 7 and this one is 17. So this is not divisible by 11 because the difference is not 0 and the difference of the digits, alternate digits, is not equal, is a divisible by 11 also. But let's check the other one. 9 and 3 is 12, 8 and 4 is 12. The difference is equals to 0. Now because the difference is equals to 0, this thing will get divisible by 11. Okay, in other words, if you must 4983, or this is BA order paired. So 4 numbers we have been able to calculate. Are there only 4 numbers? Let's see. One more thing that you can do with this expression is that because it is given in the form of an expression, I can possibly think of it like this: b minus a minus 5 is equals to 0. This is for case 2, and this case will take care of the fact that the digital difference can be equals to 11 also. Now in theory, b minus a can be 16, because b minus a 16 minus 5 is equals to 11, which is divisible by 11, which is a factor of 11, you can also say. But please remember that b minus a is nothing but single digit numbers. Can you get the difference of two single digit numbers as a two digit numbers? Is it possible? It is not possible. So b minus a equals to 16 is not possible. But what if b minus a is some other number which is a single digit number? We have already gotten b minus a equals to 5. Can I get a negative numbers also? So I'll check for it. So the negative number is 6, because minus 6 and minus 5 equals to minus 11, and minus 11 is possible. Minus 11 is divisible by 11. So we'll have to make the pairs of numbers in minus that category also. Okay, so let's do that. Again, we have to remember a very simple idea, and that idea is that the number that we are forming is of the form AB83, of which these are the alternate numbers that we need to check. So for b minus a is equals to 6, all I need to care about is 9 and 3. This pair difference will give me this thing: 8 and 2, 7 and 1, and 6 and 0. Now these 4 numbers will definitely give me minus 6, but depending upon which is the ordered pair. Now at this point, either it is AB or BA does not matter, because these are the only 4 pairs that will give you. So effectively the answer to this question is 8 only. But just for the sake of clarity, I will try to check. So I will check 9383, as well as I will check 3983. If you see, if you look at the alternate numbers, rather I'll use a different color. So if I use a different color, I'll get 3 and 3 as 6, 9 and 8 as 17. 17 minus 6 is equals to 11. So actually this thing works. So in other words, this is nothing but AB ordered pair. Let's see if this works. This is 9 and 3, which is 12, and 8 and 3, which is 11. 11 minus 3 is neither equals to 0 nor it is divisible by 11. In other words, you have to be dead sure that the numbers will be 9383, 8283. Okay. Yeah, 7183, and the last one will be 6083. Now just because I want to check, I will check one of the numbers. Let me check this number 8283, because I am a little confused with this one. So let's check this number. I don't really need to check this thing, but it's just for the mental satisfaction, I'm going to do it. So the same idea, 8283, I'll check. This is 5 and this is 16. 16 minus 5 is equals to 11, which is a number that is divisible by 11. So in fact, this is divisible by 11. So what I wanted to convey is that all these numbers are going to be divisible by 11, and the other set of numbers, if you must, the other set of numbers will be, so let me write that also down. So that will be 4983, 3883, 2783, 83 and 1683. Okay, 6 and 3 9, 8 and 1 9. So checked. These are those numbers which are divisible by 11, and the other set of numbers which are divisible by 9 are these ones. So in all, effectively there are total 8 numbers which will be divisible by 11 in this format, AB83 format. Now my dear friends, I just wanted to say one more thing before I conclude this session. It is completely fine if you don't want to do all of this. It's completely fine if you can just eliminate 1 or 2 steps, but the idea is that I wanted to give you the detailed explanation of this thing, and that's why I'm doing this. So I hope you enjoyed the video. Thank you.